Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 1 Foundation Tier from 2018. Now, this paper is out of 70 marks and it's 1 hour 15 minutes long and has 7 questions. Questions 5, 6 and 7 are higher tier questions. And question 5 appears as question 1 in the higher tier, question 6 as question 2 and question 3 is question 7 in the higher tier. So for those 3 questions I will be doing them separately and I will link it to the end of this video as a playlist. So this video is going to be out of 4 questions 1 to 4. Question 1 is on the topic from bonding structure and the properties of matter. Now in chemistry, it's slightly different to the way they structure the questions because it's a mixture. In biology and chemistry, usually each question is related to a specific topic, mainly in physics. But in chemistry, it's always a mix. They kind of mix different topics from the paper 1. There's 5 main topics. So let's have a look at question 1. This question is about structure and bonding. So it's mainly on the bonding structure and the properties of matter. Figure 1 shows part of the structure of calcium oxide. What type of bonding is present in calcium oxide? Now, calcium is a metal and oxygen is a non-metal. So it should be an ionic bonding. If it was covalent bonding, it will be between non-metals. The carbon dioxide. Macromolecular, there's no macromolecular bonding. Metallic bonding is between metals only. Figure 2 shows a particle of methane. Now, methane is an alkane and it has the formula. What we see here is what we call the structural formula, shows the structure. This CH4 is what we call the chemical formula. What type of particle is present in figure 2? It's not an ion because it doesn't have a charge. It's not a lattice. Now the calcium oxide that we saw in this is a lattice structure. It is a molecule. It's not a polymer because it doesn't have repeated units. Figure 3 shows the structure of C60. Now C60 looks like a ball. The structure of C60 is diatomic. No, it's not made up of 2 atoms. Giant ionic. No, carbon is not a metal. It's a non-metal. A fullerene. It is a fullerene. Again, giant metallic. It won't be a giant metallic. It's what we call Buckminster fullerene or buckyballs in short. Figure 4 shows the structure of graphite. So graphite is made up of just carbon. It's another allotrope of carbon. So what type of bonds is present in A? That would be covalent. There's no double bonds because you don't see any double lines. It's not ionic because there's no metals and it's not metallic as well. In graphite, each carbon atom forms bonds with other carbon atoms as shown in figure 4. How many electrons does one carbon atom use to form one bond? Well, that would be just 1. Again, pay attention to these words in bold. Otherwise, you're going to get it wrong as 3 because each carbon is bonded to 3 other carbon atoms. But how many electrons does one carbon atom use to form one bond? That will be just simply 1. An electric current passes through copper. Now, this part is actually linked to chemical changes. Figure 5 shows the apparatus used. So we have copper in the middle, and you got the two electrodes connected to a filament light bulb and a DC power supply. Actually, it is to do with bonding, not to do with chemical changes. Choose the answer from the box. Figure 5 shows that copper conducts electricity as a solid. Complete the sentence. Choose from the box. Copper conducts electricity because of the movement of delocalized, it will be electrons. Now this part is linked to electrolysis, which is to do with chemical changes. Figure 6 shows the apparatus used to investigate the effect of electricity on sodium chloride solution. So you have sodium chloride solution, which is salt solution, and inside the solution is two electrodes connected to a DC power supply and a filament light bulb. Complete the sentence. Figure 6 shows that sodium chloride conducts electricity when dissolved. This links to the properties of ionic compounds. This part of the question. Sodium chloride is made up of ions. Figure 7 shows the apparatus used to investigate the effect of electricity on solid sodium chloride and molten sodium chloride. So we have solid sodium chloride in the first part of the figure, which shouldn't light up. The bulb doesn't light up because solid sodium chloride doesn't actually conduct electricity. But the bulb lights up when it's in molten state because the ions can actually move. Now, observation, the light bulb does not light up when it's solid sodium chloride. When molten, the bulb lights up. Deduction, does not conduct electricity, does conduct electricity. Okay. Draw one line from each statement to the correct reason. Solid sodium chloride does not conduct electricity. The ions are fixed, or are they vibrating? Now they are fixed. The reason they can't conduct electricity is because the ions can't actually move, so it has to be fixed. They are vibrating in fixed positions. But just because it's vibrating doesn't mean that it's actually an explanation for not conducting electricity. Molten sodium chloride conducts electricity because the ions are mobile. That brings us to the end of question number 1. Let's have a look at question number 2, which is on the topic of atomic structure and the periodic table. This question is about the halogens, which are group 7 elements. Which group, okay, that's actually the question. Which group in the periodic table is known as the halogens? That would be group 7. Remember, group 1 is alkaline metals, group 2 is alkaline earth metals, and so alkaline earth metals. Group 0 is called noble gases. Because fluorine atom has 7 electrons in the outer shell. That's because it's in group 7. Figure 8 shows part of a dot and cross diagram to represent a molecule of fluorine, F2. Complete the dot and cross diagram. You should show only the electrons in the outer shell. So because it has 7 electrons, we've got 2 dots in this, so we've got 6, and one of them is being shared with the other fluorine, and you could draw the dot and cross in the inside, like in the shared space, like in the Venn diagram, or you can draw on the lines on the outside of each line as well, but it's better to draw it in the inside. Sodium chloride reacts with potassium bromide. Solution, complete the word equation. Now chlorine reacts with potassium bromide. So chlorine is more reactive than bromine or bromide. So chlorine will actually displace the bromide to form potassium chloride. So here they have only given you one line, so it will be bromine. It won't be bromide. Make sure that that is correct, because it's only bromide once it's formed or as a compound. So it's bromine gas. And potassium chloride. Again, you need to make sure that it is chloride, not chlorine, to get the mark. What type of chemical reaction happens when chlorine reacts with potassium bromide solution? It will be displacement. Decomposition is when it's breaking down. Neutralization is when it's an acid or a base reacts with an acid reacts with a base or alkali. Precipitation when a solid is formed. Chlorine is more reactive than bromine. This is because chlorine gains an electron more easily. Now group 7 want to gain electrons, yes. So they are all gaining electrons. An electron, it can't gain an atom, a neutron or a proton. It never happens. The only thing that happens during chemical reactions is the transfer of electrons or the loss or gain of electrons. How does the size of a chlorine atom compare with the size of a bromine atom? Now, if you look at group 7 elements, you've got fluorine, chlorine, bromine, and iodine, and astatine. As you go down the group, the atomic size actually increases. So chlorine atom is smaller than a bromine atom. Give a reason for your answer. Why would chlorine be smaller? Now, again, if you look at the order, this is in the first period. Actually, that's in the second period, which means it has 2 shells. Second, 2 shells. Chlorine has 3 shells. Bromine has 4 shells, and iodine has 5, and astatine has 6. So chlorine has less number of shells than bromine, or energy levels. So chlorine has fewer shells of electrons. Chlorine, this bit you don't really need to write. 3, while bromine has 4 shells. Chlorine reacts with chlorine to produce Ci, or chlorine trifluoride, ClF3. Balance the chemical formula equation for the reaction. So you have Cl2. Now 2IF, wait, that's not 2I. So 2ClF3 is basically ClF3 and ClF3. So that means there's 6 fluorine and 2 chlorine. So fluorine was already balanced, so you've got F2, so you need a 3 in order to balance the fluorine. Explain why fluorine is a gas at room temperature. Use the following words: energy forces molecules weak. Now, fluorine exists as molecules because it's a diatom, right? So if that's a fluorine and you've got fluorine molecules like this, there are weak forces of attraction between the molecules. So if the attraction between the molecules was strong, for example, like in water, it's much more stronger than fluorine, they'll be closer to each other and it'll form a liquid. And if it's much more stronger, then it can be a solid. So the forces between the molecules are weak, right? That actually should give you 2 marks. So we've done forces, that we've used all 3 words. We need to use the word energy. Why is it a gas at room temperature? Because you need less energy to break these bonds. So even at room temperature, the temperature is high enough for the molecules to break these bonds to form gas molecules. So very little energy is required to break these bonds. Now for 3 marks, they have given a lot of space for this question. That brings us to the end of question number 2. Let's have a look at question number 3, which is on chemical changes. This question is about acids and bases. Which ion is found in all acids? That would be H+ ions. Zinc nitrate can be produced by reacting an acid and a metal oxide. Name the acid and the metal oxide used to produce zinc nitrate. Now nitrates are formed by using nitric acid. So where would you actually get the zinc from? Well, it has to be the metal oxide. That should be zinc oxide. In an equation, zinc nitrate is written as ZnNO3 close brackets 2 AQ for aqueous. What does AQ mean? It means it's dissolved in water. The pH of a solution is 8. Some hydrochloric acid is added to the solution. So if the pH is 8, it's slightly alkaline. So you're adding hydrochloric acid. Suggest the pH of the solution after mixing. So it could be 7 or below 7. So your answer could be anything between 0 to less than 8, right? So you can say 7.5 as well. So that's why I'm not saying 7. So let's say 7, because they are adding some hydrochloric acid. Table 2 shows the solubility of 3 solids in water at room temperature. So you've got phosphorus oxide, 50 grams will dissolve in 100 centimeter cube of water. Silicon dioxide, it doesn't dissolve at all. Sodium hydroxide, 100 grams actually dissolves in the water. So it's a ratio of 1 to 1. Okay. A teacher labeled these 3 solids A, B, and C. She gave the student an information. Solid A, colorless solution, pH of the solid is 14. So it's quite alkaline or strongly alkaline. Colorless solution with a pH of 2. Solid does not dissolve with a pH of 7. So if it's not dissolving, that should be the silicon dioxide, isn't it? Okay. Describe a method that you could use to identify each of the 3 solids A, B, and C. You must use an indicator in the method. Now, if you're using an indicator, you would use something like a universal indicator. The reason is, if you use a universal indicator, this would color the solution. If you add a universal indicator, it should turn purple. This should turn orange or red, and this should be green. So 4 marks, right? Again, for the 3 marks, they actually gave much more space than for this, right? So add universal indicator. To each solution of A, B, and C. So what will be the results? 2 solution of A turns purple since it's an alkali, so it's sodium hydroxide solution. So it's hydroxide solution. 3 indicator turns I'm going to actually change this. I've said orange, let's say red, right? 1 and 2 are mainly red anyway. So solution of B turns red since solution is acidic, which means it is phosphorus oxide. Turns red since it is acidic, so it's phosphorus oxide. 4th bullet point. Solution of C is 7. The pH is 7. Solid does not dissolve. So C is silicon oxide since it does not dissolve in water, so pH is 7. That brings us to the end of question number 3. Let's have a look at question number 4, which is on the topic of atomic structure and the periodic table. This question is about the elements in group 2 of the periodic table. This question is about the elements in the group 2 of the periodic table. So if it's group 2, these are alkaline earth metals, which has okay. Figure 9 shows the position of 4 elements A, B, C, and D of the periodic table, which element is in group 2? This will be in group 2. So this is group 1, this column. So this is group 2. This is 0, 7, 6, 5, 4, 3. This would be the transition metals. So group 2 is B. Group 2 metal carbonates break down when heated to produce a metal oxide and a gas. So metal carbonate breaks down to produce metal oxide and the gas. Name the two products when calcium carbonate is heated. So the metal carbonate is going to be, if you're reacting calcium carbonate, you should have calcium oxide and carbon dioxide. Now, this type of reaction is called a decomposition reaction. What type of reaction happens when a compound breaks down? That's decomposition. Burning is combustion when it produces carbon dioxide and water. Neutralization is between an acid and alkali. So burning produces, now the bits that I'm writing, these are notes. It's always best to actually make these notes as form of revision. Burning produces carbon dioxide plus water. Neutralization is an acid reacting with a base of alkali to produce salt plus water. Reduction is removal of oxygen or the loss of oxygen or gain of electrons. And a positive ion is negative ion is formed. The metal carbonate takes in energy from the surroundings to break down. Now this question is to do with the topic 5 on chemical energy changes. So if it takes in energy, then it's endothermic, right? Exothermic is when it gives out energy. Electrolysis is when you're splitting ionic compounds using a current. Combustion again is the formation of carbon dioxide and water when any substance reacts with oxygen. Figure 10 shows the volume of gas produced when a group 2 metal carbonate is heated. So that volume of gas is the carbon dioxide. So as the mass of carbon dioxide, as the mass of group 2 carbonate is increasing from 0 to 100, the volume of gas also increases. It's a straight line, so it's a linear relationship, and it looks like it is directly proportional as well. So the student collected 5.2 dm cube of gas. What mass of group 2 metal carbonate is heated? No, 5.2. Right, so 0 to 2. So 5 boxes divided by 2 is going to be 1.2 dm cube. Each box is 1.2. No, that can't be right. Sorry, that's wrong. It should be the other way around. That's 2 divided by 5. That's 0.4 dm cube. So each box is 0.4. Okay, so 5 is there. No, sorry, 5 is here, halfway between 4 and 6. 5.2 is just above that line, so it should be here. And if I drop that line, it should be halfway between mid of the second box. So 0 to 10 is 2 per box, or 2 grams per box. So that will be 33. Now the marking scheme actually accepts any answer between 31 to 33. So let me see. So it's actually nice. Increase that size just so that it's visible. You can see at 5.2 is right over here. So it's actually 31. So it's accepting from there. 31 to 32. 33, sorry. Okay. Let me scroll back again. Calculate the mass of the group 2 carbonate needed to produce 24 dm cube of gas. Use your answer from 4.3. So now they're asking you to use your answer from 4.5, which is basically this answer. Let's use it as 33. Now, can you work it from the graph? Now, if you want to produce 24 dm cube, your scale is only going up to 16 in this scale, so you can't actually read 24. So you have to work out. The easiest way to work out is what is the volume of gas produced by 1 gram, or how much does it take to produce 1 dm cube. We can do that. So if I take it as 33, divide that by 5.2, I would get 6.346 grams per dm cube. So I would need 6.346 grams to produce 1 dm cube. So I can multiply that by 24 to find the total mass. So 6.346. So for 24 dm cube, multiply that by 24, I would get 152.3 grams. So I can round it off to a whole number, 152 grams. A student heated different masses of a group 2 carbonate. Now before I go, I want to try a different method to see. But if I find the mass actually needed for 12 dm cube, that's basically here. So that's 74 grams. 74 grams. So multiply that by 2, 148 grams. So if I could actually do that as well. So for 12 dm cube, I would need 74 grams. So multiply that by 2, I would need 148 grams. So if I only need 148 grams is actually accepted in the marking scheme. So the marking scheme actually accepts 104, any answer between the range of 143 to 153. That's actually more in the middle. A student heated different masses for a group 2 carbonate. The student measured the volume of gas produced. Figure 11 shows the graph of the student's results. The student calculated the gradient of the line in figure 11. The student made 2 mistakes. So what are the mistakes? Volume of gas and the mass of carbonate. Correct formula for the gradient is increase in volume of gas. So that's basically the y-axis over here. And increase in mass of group 2 carbonate, that's the x-axis. So let's see if they got it right. So this is 1000, that bit is correct. That's 250, so that's 750 is correct. This is 124, isn't it? So that's not 5, so that's an error. So that should be 4 minus 1, so that should be 3 grams. So that's your error there. Student's calculation equals 4 divided by 750, so that's y over x. So but we should have actually divided 3 by 750. Identify the 2 mistakes the student made. We've calculated or spotted 1 error. What's the second error? Well, the second error is what I've actually made the second error. So it's not 3 over 750. So that's y value is 750 divided by 3. That should be the correct. So mistake 1 is volume of gas equals 3 centimeter cube, not 4 centimeter cube. Mistake 2, calculation should be 750 divided by 3 to give 250 centimeter cube per gram, not 3 or 4 over 750. So the calculation is 750 divided by 3, that's 250. For mistake 2, you could say the numbers are the other way around as well. A student repeated the experiment with a different group 2 metal carbonate, XCO3. So X is the unknown metal here. The relative formula mass of XCO3 is 84. The relative atomic mass of carbon is 12, oxygen is 16. Calculate the relative formula mass of X. Name metal X, use the periodic table. So the relative formula mass of XCO3 is 84. So which is basically saying the entire mass of XCO3 is 84. So the mass of X plus there's 1 carbon plus there's 3 oxygen. Oxygen is 16, so the 16 times 3 is 84. So 16 times 3 is 48. So 16 times 3 is going to be 48, plus 2 is 50 and 60. So X plus 60 equals 84. X equals 84 minus 60. That's going to be 24 grams. Now, which atom has the relative formula mass of 24. That should be magnesium. That brings us to the end of question number 4. Now, as I said at the start, question number 5 is the higher tier question, which links to chemical changes on electrolysis. So I've done a separate videos for these questions. I will link it to the playlist for this paper, so you should be able to watch them and follow through. So again, just to show, question number 5 is out of 8 marks. Question number 6 is on the topic of atomic structure and the periodic table, which appears as question 2 in the higher tier paper, and it's also out of 8 marks. And question 7 is a 6-mark question, which appears as question 3. So there's a pattern here. So if you're a higher student, you would expect the 6-mark question to appear right at the start in your chemistry paper for combined science. That brings us to the end of the paper and the end of this video. Thanks for watching. This is Ketish here for EduWise 101. If you find this video useful, consider subscribing to the channel so that you should get notifications when I upload the chemistry papers. And check out the channel for biology and chemistry physics papers as well, both combined science, and this is separate science for the AQA specification at the moment. Thank you. Bye.